Hi everyone, welcome to Vedantu NEET English. I'm 𝐂𝐡𝐞𝐤 𝐎𝐿, your chemistry master teacher. So how are you all? Am I visible? Am I audible to everyone here? So bacha, everybody in the chat box, am I visible? Am I audible? Wait, let me check here line by line. I think that got cut. Don't worry. Just give me a minute. Okay, so are you all ready or not, everybody? So, ma'am, why you got late? Why I got late? Because today itself I came back to my hometown, right, from Delhi, and because of the weather conditions, my flight got delayed and so much traffic. So, finally I reached home 30 minutes back, and I was so much hurry that I have to, start the class. I have to be there, teach the students. I was preparing the PPT, making the slides for you in the airport, right? In the cab, I was doing all that stuff, and everybody was like, is she a student who is like studying books and, taking the screenshot? What exactly this girl is doing? So yeah, this is what I was doing. With everybody else was just listening to the music. I was doing this. So yeah, these are the little sacrifices that we teachers makes for you, right? Okay, so everybody, are you ready for this chapter? Now, why NCERT line by line for inorganic chemistry specially? Firstly, though, you have to do NCERT for physics, chemistry and bio. That's a for sure, right? But for inorganic chemistry and bio, it's must. That means you have to do each and every single line. You will see so many questions out of that. So I want all of you to pick up one pen or pencil or highlighter along with the NCERT book. Yes, hard copy will be great here, right? What is the reason behind that? Because I have slides for you in which we are going to see the NCERT line by line, and I'll underline the important lines. And we will see what kind of questions will be there from these lines. There will be assertion reasoning question, there will be statement based question, different type of questions from these lines of inorganic chemistry. You can see the previous year question papers, right? It's not only about NEET, it's also about JEE mains also. You will see direct questions from these lines. But for that, there are so many kids who are like, ma'am, I have studied NCERT for like 5 to 6 times. Firstly, everybody in the comment section, how many times you have studied this chapter from the NCERT? I want to know my audience, I want to know my dear students, how many times you have studied this chapter, not whole NCERT, only this chapter from NCERT, and how much you remember. Let us see in the comments how many times you have seen that. I'm expecting at least one time. I'm expecting at least one time, but you can be very real about it. You don't have to, brag here that, okay, I have studied it for 5 to 6 times. If you have studied 0 times, just say it. You have studied 5 times and still you are not able to retain that, just say it, okay? Because I want to know your weaknesses. Only then I will be able to work on your weaknesses, right? 0 only once, 1 time, 2, 3 times, ma'am, 1 time, 2 times, 1 time, 0 time. So mostly the average number is 0 to 1 times, right? Either 1 time or 0 time. So what you have done, you are like, okay, the periodic table is arguably the most important, this, and you have studied that and underlined the questions, right? But now you will study the NCERT along with it, and we will see that in which manner should we study it. So are you all ready for that? Do you have pen? Do you have that NCERT notebook? Because similarly, we are going to do this for P block. We are going to do this for DNF block, right? Firstly, I will pick up the block chemistry, right? Because now we are doing periodic classification. Block chemistry is similar to this, right? Chemical bonding is mostly theory based. So in the end, we will do chemical bonding, then coordination chemistry. Right, bacho? Okay, everybody, if you're ready, then green hearts in the chat box so that we can start without wasting even a single minute. Okay, ji, chalo, let us start. Ma'am, thanks for this series. Yes. Thanks to Vedantu NEET English team. Thanks to Gopika ma'am, Baswa sir, Diksha ma'am and Shreyas sir. Right? Okay. So now, I'll take one highlighter along with you. Okay, I'm going to highlight the important points here. First, let me check the highlighter here. Okay, so I'm also going to highlight the things along with you. Let me mark my pen here. Okay, do you have a yellow highlighter you have? Okay, I'll also have yellow highlighter. Okay, this is how you're going to mark things along with me, right? If you have only simple pencil, then you can do that also, right? Now, the first paragraph is of no use, right? This paragraph is of no use. Nothing, they are just saying that why there was need of periodic table. The periodic table is arguably most important concept. Why it was needed to classify the elements, right? We cannot study the elements like, okay, I want to study the elements and the properties of each of the element. That is very difficult. That is why this concept was made, the both in principle and in practice. It is everyday support for students, right? For your support. That is why you say all these are metals, all these are non-metals. These are the properties of metal. From left to right, this happens. From top to bottom, this happens. You just need to remember the trends and the exceptions. You don't need to remember all the 118 elements along with the chemical and the physical properties. The reason is periodic table. So that is what it is given here. It is remarkable demonstration of fact that chemical elements are not a random cluster. They are not a random cluster of entities, but instead display trends and lie together in families, right? It's not like they are random clustered. They have some kind of trend, and that is why that is the kind of trend that the scientists were going to observe after this, right? Okay, so that was given by C book. The names are not important for you. Okay, so all these things are the introduction. So that is not, they will ask in NEET. Okay, so that you should know that this they are not going to ask in NEET, right? Now, coming to the first part. Now, here the number of elements are important, not that important, but still you need to understand that how many elements were initially present there when this periodicity concept came in their mind, right? Periodicity simply means repetition of things at a particular interval. For example, I say that, okay, I wash my hair after every third day. That means that is periodic thing that is going on. After every 2 days, on the third day, I wash my hair. Okay, so that is your periodicity that is happening after a regular interval, right? Okay, so we know by now the elements are basic unit of all type of matter. That what is basically matter is everything around us is matter, and they are divided into elements. So elements are basically a kind of matter that is further has its division that we are going to study here. In 1800, only 31 elements, right? Not so many elements were known, only 31 elements were known. After that, they said after that in 1865, mainly after 65 years, it got doubled to 63 elements, right? Firstly, only 31, then 63 elements were known. Then, bacha, at present, 118 elements are known, right? Of them, the recently discovered elements are man-made. That means the recently discovered elements are artificially. That most of the elements that were discovered before were natural elements, right? From the ores, right? They were discovered. That you must have done in metallurgy, right? If you are a dropper, if you're not a dropper, that is already skipped in NEET. Okay, that is not in your syllabus in NEET. That is the part of metallurgy, the kind of ores and the extraction of the ores. That is not in your syllabus, right? Then, bacha, they are saying that efforts to synthesize new elements are continuing. Even now, they are trying to have new elements, right? Okay. Then, bacha, with such a large number of elements, it is difficult individually study these elements. To ease out this problem, scientists search for systematic that they, okay, so what is the kahani going on? They are saying that so many elements, we have 114 elements here, right? Then they are saying to study each and every element is not possible. So we have to divide that into classification. We have to make some classification for that. And for that classification, there comes this thing. Now, this is the classification that we are going to study here. So for classification, what they are saying that classification of element into groups and development of periodic law and periodic table. Now, this periodic table, this modern periodic table that we are studying, it was not initially like that. It was firstly made in terms of the Bernier triads, right? So where is this Bernier? The German chemist John de Bernier in early 1800s was the first to consider the idea of trends among the properties. So who was the first person? Bernier was the first person to think about this thing, right? Then what exactly he did? He made triads. What triads? Triad means set of 3 elements. Now, what are these 3 elements? Basically, he said that the first element and the third element, that is the average of, right? That means they are saying, if I want to calculate the mass of, sodium, if I want to calculate the mass of sodium, that will be equal to the mass of lithium plus mass of potassium divided by 2. That means the mass of the middle element is equals to the average of first and the third element. So in generalized form, we can write it here. The middle element, or you can say the middle element is the weight of first and the weight of third. Or you can just directly write W2 divided by 2. That is a simple thing that he told. Now, what kind of question can they ask from this? They will ask a simple question based on which of the following is not a Bernier triad. So in your NCERT table, it is mentioned that this is a Bernier triad, this is a Bernier triad, this is a Bernier triad. Except for this, nothing is a Bernier triad, right? So if in the option it is written lithium, sodium, potassium, that is a Bernier triad. Li-na-ki. Okay? Then car, scooter, bow. That is calcium, strontium, barium. That is also a Bernier triad. Right? Then chlorine, bromine and iodine are also a Bernier triad. So which of the following is Bernier triad? These 3 are the sets of Bernier triad. And by this, I want everyone to write down in your NCERT notebook. Write down in your NCERT notebook which of the following. Write down in your NCERT notebook. Why I asked you to bring one pencil and pen, right? The reason is this only. Write here why or which of the following. Just write which of the following is Bernier triad, right? Now, why I am doing this? Because I don't want you to read this NCERT again. I don't want you to read this NCERT again after 2 months, right? So what we are going to do after 2 months, what we are going to see? We are just going to see the highlighted points. We are going to see these tables. We are going to see the questions here, right? In the third revision, we are going to see these questions and try to answer us ourselves. That okay, which of the following were the Bernier triad? Lithium, sodium, potassium were the Bernier triad, right? Calcium, strontium, barium were the Bernier triad. Then chlorine, bromine, iodine were the Bernier triad. Okay, fix, done, set, right? Already done. Okay, bacha? So that is how we are going to read the second thing. Now, next is the periodic reoccurrence of properties. Now, what he is saying this thing. Wait. I forgot to read this thing, right? By 1829, he noted a similarity among the physical and chemical property. How this triad came in his mind. There was just few elements there. Back then, there was just few elements. He saw there is some kind of similarity. This is the similarity that he saw, right? And he named these elements as triads, right? In each case, he noticed that middle element of each triad, beta, write it here, middle element of each triad, just underline this here, middle element of each triad has an atomic weight about halfway between the atomic weights of other two. That means the average of other two. Also, the properties of the middle element were in between those of the other two members. That was the in between. That means if it is increasing, it will increase. It is decreasing, it will decrease. That means some kind of similarity he was able to understand, right? Then he said that the relationship referred to as law of triads. He said these are the law of triads. Seemed to work only for few elements. It was dismissed as a coincidence. They said that there is nothing. I told you one rule of inorganic chemistry. It should be applied everywhere. If that theory is not applied everywhere, the other scientists are going to dismiss that theory, right? Competition was there. So that is why they said, okay, this theory is not applicable for other elements. Maybe this is just a coincidence. There is no periodicity that is actually lying here. The next reported attempt to classify, now this is, most of the students don't know this. And most of the students just skip this part. You never know, maybe in NEET 2025, you will see a very small chintu-mintu question on this, right? You will say, oh my God, I didn't open my NCERT only. It was just hiding behind somewhere in NCERT, just 2 lines of NCERT. What is that? That is, the next reported attempt to classify elements was made by French geologist 𝐂𝐴𝐵 𝐏𝐥𝐚𝐲𝐥𝐢, okay, 𝐏𝐥𝐚𝐲𝐥𝐢 in 1862. Right? He said that he arranged the then known, the elements that were known at that time in order of what? In order of, write it here, in order of increasing atomic weights and made cylindrical table of elements. Oh my God, what he is saying? He made a cylindrical table of element. He arranged that in such a manner that these are occurring, and he made a cylindrical table. That was not understandable by everyone out there, right? So that was a very confusing kind of table. That is why it didn't got that much importance back then. Okay, so that was just ignored by the scientist, right? So what exactly happened with him? The periodic reoccurrence of properties, this also did not attract much attention. That means after the Bernier, there was also some other thing that was a cylindrical table. That did not got that much attraction, right? The English chemist, now it did not got that much attraction. After that, what happened? The English chemist John Alexander Newland. So now this is your singer, that is the Newlands, right? He was very much interested in singing. So he produced this Newland law of octaves. Now what is this Newland law of octaves? This is sa re ga ma pa dha ni sa ni dha pa ma ga re sa, right? So what is that? Sa re ga ma pa dha ni sa. That means 7th and the 1st element, or you can say the 1st and the 8th element, right? They have the similar properties. This is sa, 8th is also sa. Sa re ga ma pa dha ni sa re ga ma pa dha ni sa, right? The 1st and the 8th sa is same, right? That is the Newland law of octave. He said that the 1st element will be equal to, the properties will be equal to the 8th element. Now what he exactly said? He propounded a law of octave. He said that he arranged the elements in increasing order of their atomic weights. Now everyone was doing that on the basis of atomic weights. Nobody was thinking about atomic number. Everyone was arranging that on the basis of experimentally devised atomic weights, right? Now he said that, noted that every 8th element had properties similar to the 1st element, right? Sa re ga ma pa dha ni sa re ga ma pa dha ni sa. Now the relationship was just like 8th note, right? The relationship was just like 8th note that resembles the 1st in the octaves in the music. That means octaves, right? Sa re ga ma pa dha ni sa is called octaves. Now, Newland's law of octaves seemed to be true only for elements up to calcium. Now, this is a very, very, very important thing. That means they are saying that was only applicable, that was not applicable for heavier elements. That can be asked to you, Newland's law not applicable to. This is the first question that they can form, or you can say, I can just write it here, the third question, right? The third question that can be formed from here. Other what they can say, although his idea was not widely accepted at that time, he for his work was later awarded by Royal Society London. Okay, that means only this can be, only this they can ask from this particular paragraph, or they can ask you about law of octaves, which is very simple. So that is why they are not going to ask this. Maybe they will ask till which element that was applicable. So it was applicable till calcium, right? Then bacha, this is the thing. So you can see till calcium it was applicable, right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, potassium, calcium, right? Till this it was applicable, right? That means you can see this is sa, re, ga, ma, pa, dha, ni, sa. Lithium, sodium, potassium. That was also true for law of, that was also true of law of triads, right? This was also true for law of, this was not in law of triads, right? Beryllium, magnesium, calcium. Here boron, aluminium has similar properties. Carbon and silicon has similar properties. Nitrogen and phosphorus. Then you have oxygen and sulfur. Then you have fluorine and chlorine. These have similar properties, right? But it was not applicable for heavier elements. Not for, you can, whatever I am writing now, I want all of you to write it down on the side of your NCERT. That is why I am writing it here. Okay, not for heavy elements, right? This was not for heavy elements, right? So that was also discarded. Now till we have three things, right? Now what will happen? Now a tragedy will happen with Lothar Mayer, as I told you before also. Our Lothar Mayer is very dil toota ashik, right? Why so? Because Lothar Mayer did something, but he was not actually appreciated for that. How will you feel, right? You actually know na, some students, they did really well in NEET 2024, right? They scored 650, 660, but now they are not getting admission. So this is what exactly happened with Lothar Mayer at that time, right? What he must have felt at that time, right? So what exactly happened? So the periodic law as we know it today owes its development to the Russian chemist Dmitry Mendeleev ji, right? He was the Mendeleev periodic table. Firstly there was Mendeleev periodic table, then there is modern periodic table, right? So the modern periodic table is based on Mendeleev periodic table. That is how they got the idea, right? Now it was given in 1834, right? And here the German chemist Lothar Mayer. Now ma'am, both of them worked on the same thing? Yes. Both of them worked on the same thing. This was in Russia, this was in Germany. Both of them were working independently on that thing, making some periodicity out of it. Right? In Germany, Lothar Mayer was doing this and that, and in Russia, he was doing this. Right? What happened exactly? Thing happened, he was doing in 1834, he was doing in 1830, ma'am, then Lothar Mayer wins. Right, ma'am, then Lothar Mayer should win. What exactly happened? Lothar Mayer made the table, or you can say the graph first, but he submitted it first, right? And moreover, that was much easier. Mendeleev made it in the form of a table. A table is very easy to understand as compared to a graph, right? If I make this thing in terms of a graph, you will get confused. Ma'am, what is this? This and this is this, right? So this scientist wanted to make it very simpler for the students, when we wanted to make it very simpler for the junior scientists and the other people who are keen interested in knowing science, right? So that is why they actually, after this, they also appreciated Lothar Mayer, but the full appreciation was given to more to Dmitry Mendeleev, right? So what exactly happened? Working independently, both the chemists in 1869 proposed that on arranging elements in increasing order of, what is that? In increasing order of the atomic weights, similarities appears in physical and chemical properties at regular intervals. At regular intervals it was happening. That means he was not here for 5 to 6 to 10 to 20 elements. No. He said all the elements I am going to arrange here. That was amazing, right? Lothar Mayer plotted means he plotted a graph, right? The physical properties such as atomic volume, melting point, boiling point against the atomic weight. Now this is a very important question. See, two questions can be there. I'll just write it down here. Okay, because after this you will see one more graph plotation, right? So that is also very popular. So you might get confused there. He plotted graph of, or you can just write it here. Lothar Mayer plotted graph between dash. Okay. So it is the third question. Lothar Mayer plotted graph between dash and dash. right? So you can just write it down here, right? Okay, yes ma'am, yes ma'am, very good. Now what exactly happened after that? What exactly happened after that? Trust me on that. After reading these NCERT with me, you won't be able to yell. You don't need to read the NCERT again, right? You'll be happy with that, right? You just need to retain that thing in your head, and that also I will tell you the very important trick for that, right? So that is the symbol. Lothar-Meyer plotted the physical properties such as atomic volume, melting point, boiling point against this and obtained a periodically repeated pattern. Unlike Newland's, Lothar-Meyer observed a change in length, very, very important line, that repeating patterns. That means he was not saying that, okay, there was repetition to a same extent. He was saying there was repetition, it was increasing. The difference was increasing. That means it was not a periodic. I'm not saying, it's like I'm saying I'll wash my head 3 days. After every 3 days, then I'm saying I will wash my hair after every 4 days. Then I'm saying I wash my head after every 5 days. Then after every 6 days, and after every 7 days. That means I'm increasing the interval here, right? So this is what they are saying. So Lothar-Meyer had developed a table of the elements, and after that he also made it into a table. But by the time Mendeleev had also proposed that, so that is why Mendeleev got that appreciation, though the result was same. Right, result was completely same. However, his work was not published until after the work of Dmitry Mendeleev. है ना? So sad. है ना? I always, whenever I teach students this, I always feel so sad for Lothar-Meyer. Always I feel so sad for Lothar-Meyer. Like the same amount of hard work he have done. In fact, 4 years before also Mendeleev he has done, but still his work was not published before Mendeleev. So sad. Right. So until after the work of Dmitry Mendeleev, the scientist who is generally credited with the development of modern periodic table. Okay. So that is a very harsh reality of science that we just saw here, that okay, Lothar-Meyer was not appreciated here. Right. Do you also feel very sad for Lothar-Meyer? I feel very sad. Right. So much hard work, but still he was not appreciated for that. While Dubernier initiated the study of periodic relationship, it was Mendeleev who was responsible for publishing the this and this. Okay, again NCERT is also very sad about it. You can see NCERT is also like why this happened. Like they are also like, while Dubernier initiated the this Mendeleev who got the responsible for this. Even Dubernier, who actually initiated the periodicity thing very first time, he was also not given any credit for that. Lothar-Meyer though gave the same results. He also was not given the result. It's about luck. Sometimes it's also about luck, right? We can see that. So what exactly was this law? This law was that the properties of elements are a periodic function of their atomic weights. That means that as the atomic weights are increasing or decreasing, along with that the physical properties, the chemical properties will differentiate, right? That is a periodic classification based on the atomic weights, right? And how does Lothar-Meyer curve look like? How does it look like? It looks like this, okay? Like this, and then this, and then this, and then this, okay? This kind of curve was there. He also told about the peak points, the ascending points, the descending point, the constant points, right? Okay, that I have already told you. Which are those things that are not in NCERT? I have taken a periodic classification, different chapter, right? Where I have taught you all the things that are not in NCERT, right? But to read the NCERT, these things are also very important, because most of the time the question is from NCERT only. But just to, I don't want you to take any risk. That is why I have also covered those topics that are not there in NCERT, little topics, right? Okay. So now next part, bacha, here is, next part is about Mendeleev Sahab. Now what did Mendeleev did? Mendeleev arranged elements in horizontal rows. Now please don't say that horizontal rows are, ma'am, periods. According to Mendeleev, these were not periods. This can also be asked to you. According to Mendeleev, horizontal rows were periods, series, groups, Vertical columns, what? They were the series, right? They were not the periods. He didn't name it periods. That was given by modern periodic table. That was, I'll tell you after that, right? So vertical column, he said that what? Vertical columns are groups only, but the horizontal rows, that means these kind of rows were series. These columns, these vertical columns were the rows. These vertical columns were the groups here, right? Then what he said that horizontal rows and vertical column in order of the increasing atomic weight, such as that the elements with similar properties occupied same vertical column or group. That means he said that the element with same property will be in the same group, right? Then what he said, Mendeleev's system of classifying elements was more elaborated than the Lothar-Meyer's. Now, just because Lothar-Meyer gave a graph based on that, but Mendeleev, he gave proper table based on that. He properly classified that among periods and then groups, right? Basically, he made it easy for the other people to understand that, right? So, it's not only about just discovering things, you have to also make things understandable to the other person. That's what we can learn from here, right? So, Mendeleev's system of classifying elements was more elaborated than Lothar-Meyer. He fully recognized the significance of periodicity and used a broader range of physical and chemical properties. But he also did some jugadi kaam here. So, let us see what he did here. In particular, Mendeleev relied on the similarities, right? So, his main goal was to find out the similarities. Even if there was some kind of, demerit was going on there with the atomic masses. For example, he had to, shift or exchange it with, replace it with the other atomic masses which is less, right? He used to just prioritize what? Similarities. If he has an option that, okay, here this is element number 1, this is element number 2. This has more atomic mass than this, right? But the properties of third element with this element is same. So he used to rely more on the similarities than the atomic masses. But his law was based on the atomic masses. So there was some kind of, jugadi kaam he had done here, okay. So we will see that. From there only question will come in the NEET exam, right? So in particular, Mendeleev relied on the similarities in the empirical formulas. Now, ma'am, what is this? In the empirical formula, they will ask you, the Mendeleev periodic table was based on atomic masses, that too we know. He relied on the similarities in which thing? He relied in the similarities of the empirical formula that you can see from here. That you can see in the table itself. Let me show you the Mendeleev periodic table. Bacha, can you see that? Can you see the table here? Can you see the table here? Now, these are the empirical masses. Like with oxygen, it's R. This group number 1 is R2O. This group number 2 is RO. Group number 3 is R2O3. Then group number 4 is RO2. And these are the different kind of, formulas that you use to, empirical formulas that it used to make with hydrogens or the oxygens, right? These are the hydrides. These are the oxides. This is making R2O5. This is making RO3. This is making R2O7. This hydride is RH4, hydride is RH3, hydride is RH2, hydride is RH. This is also important for you. Usually students just skip it, right? If you really want to crack NEET with 720 marks, then you cannot skip even these parts. You have to know, according to Mendeleev periodic table, group number 3 used to make R2O3 kind of oxide. Group number 4 used to make R2O kind of oxide. This is what you need to remember here. Right? So this is based on the empirical formula of oxides or the hydrides. Right? Okay, ji. Now, formed by the elements, he realized that some of the elements did not fit with his scheme. Some of the elements, he was like, okay, the atomic masses and the similarities are against each other. So what should I do? I will give preference to the similarities, like, okay, chill, no worries, no tension. Right? He was completely chill. He was like, okay. So what he did, classification, if the order of the atomic weight was strictly followed, then what he decided, he ignored, right? Ignore your problems, just like Mendeleev ignored the atomic weights here. That's it. Life will be sorted. So atomic weights, thinking that the atomic measurements might be incorrect. Atomic measurements might be like, okay, I am right. The kind of confidence, bro, right? The confidence level was next level. He was like, okay, the atomic masses might be wrong, but I am right. Okay, but I am right. I cannot be wrong. So what you do? Just exchange the atomic masses. But I have huge respect for this scientist. Reason being, he did great discoveries, right? Great discoveries he did. Okay, that is just to make, class little bit fun. I don't want you to sit here like this. Ma'am, okay, this is what Mendeleev did, ma'am. So what to do, ma'am? What to do? Okay, I don't want you to be like that here. Okay, just chill, relax, and focus on studies and have some, smile in between. There is no cost of smiling, right? It's totally free of cost. Trust me on that. It's totally free of cost. Okay, so ignore the order of atomic weights like, yo, bro, thinking that the atomic measurements might be incorrect. Okay, it's like, okay, I am right. I don't care about other people. And place the elements with similar properties together. He's like, okay, you all sit together, just chill. Then what he said that, for example, now this is very important. Why this is very important? Because the example is given in the question, right? Whenever you see the example in the NCERT, then you must focus on that example. Reason being, because that exact example is repeated in the NEET exam. Iodine with lower atomic mass than that of beryllium, right? Beryllium had more mass as compared to iodine, right? But what exactly he did, iodine was placed along with fluorine, chlorine and bromine. Now you will say, ma'am, yes, they will be placed together only, na? They are halogens. But at that time, they had no idea about the halogens, right? At that time, they had no idea about what is this halogen, why they are put together. They had no idea about valencies. All this not known to them, right? So how he just said, okay, the properties are similar. That is why I don't know about the masses. The properties are similar, so I'll just put them together, right? Because of the similarities in the properties. At the same time, keeping his prime aim of arranging the elements in similar properties in the same group, he proposed some of the elements were still undiscovered. That was the biggest achievement of Mendeleev. That is why he is respected so much. Reason is he gave the properties of some undiscovered elements. Now they will ask you which are these elements. So basically, for example, you have gallium and germanium. They were not discovered at that time. These elements were not discovered, but he named these, he gave the properties of these elements. 𝐂𝐴 means before. So what he said, Mendeleev published his periodic table. He left the gap under aluminium, right? A gap under silicon. The gap under aluminium is called 𝐂𝐴 aluminium. The gap under silicon is called 𝐂𝐴 silicon, right? That means under that silicon, there will be some element. I don't know which is that element, but it will be discovered in future. For example, some scientists today said, okay, this thing is not, this after 10 years, this thing is going to happen, right? And that exactly happened. Then you will say, no, oh my God, that scientist has predicted that. You will have that respect for that scientist. Similarly, this happened here, right? So just mark it here, 𝐂𝐴 aluminium, 𝐂𝐴 silicon, right? And write the question here, write the question. What are the undiscovered elements by Mendeleev? Okay, they can ask you this directly. Then, bacha, Mendeleev predicted not only existence of gallium, he also gave the properties. He was like, okay, after some time, these two elements, these kind of elements will exist with exactly these properties, right? That is general physical properties. And what were these properties? You can see. That was the predicted one and that was the found one, right? Predicted was 68. Found was 70. Oh my God. Predicted was 5.8. Found was 5.94. Oh my God. We don't even know the full question. That, ma'am, even then we are not able to solve the question. He just predicted something which was not discovered. He predicted the properties, right? Based on the trends, based on the periodicities, right? That was the biggest achievement. He said that the melting point will be low. That was around 302, right? That was low only in comparison to this. That is in thousands. that is around 1200, right? He predicted the formula. He said if it makes an oxide that will be of E2O3, that can be asked you in the question. They will ask you 𝐂𝐴lminium or they will ask you gallium. Anything they can ask you, forms what kind of oxides? Answer will be E2O3, EO3, E3O2, EO4. Tick answer E2O3, right? 𝐂𝐴lminium forms which kind of halide? ECl3 kind of halide. That means basically he was saying that this has +3 valency. At that time they didn't knew about this, but yeah, they are saying that aluminium has +3 valency, right? So now that is how gallium was forming the same kind of oxides and halides, right? Then predictors was 72, it was 72.2, 5.5, 5.36, high, and that was high. Oxide formula is EO2 and the halide formula is ECl3, and same was discovered here, and this is very, very, very important. These two things are very important. Full NCERT is very, each and every single line, the tables here, understanding the tables, the questions out of the tables, everything is very important here. He's saying astrologist. Yeah, he was that level of astrologist. Yeah. Now, okay, so this was basically how Mendeleev periodic table used to look like, right? So you can see this was group number 0. Now group number 0, noble gases were not discovered at that time, right? They were added after. It was the advanced form of Mendeleev periodic table. Noble gases were not there at that time. This can be asked in the question in the NEET exam. Were noble gases, everybody in the chat box, were noble gases discovered at the time of Mendeleev table? No, when Mendeleev was making this table, at that time there was no group number 0. There was no noble gases, those were discovered. Group number 0 was added after that. After he made this table, it was added, right? So this, make sure this is not there, right? This is, he gave only 8 groups, that is 1, 2, 3, 4, 5, 6, 7, 8. In all these groups, what he said, that is divided into 2 parts, A and B. Also, he gave one thing, that group number 8 is divided into 3 parts. Okay, mostly it contains transition elements, but yeah, it is divided into 3 parts. Okay, and he also had so many abnormalities here, right? He was not following the atomic weight as such, right? He was not following his own law, right? But the good part was he was able to discover, he was able to correct some of the atomic masses like beryllium. He was able to correct the atomic mass of beryllium. He was able to discover the properties of undiscovered element. That was his achievements. That is why he is respected so much, right? Okay. Now, what else is there? We must bear in mind that when Mendeleev developed his table, chemists knew nothing about internal structure of atom. Very, very important. They had no idea about what is this quantum number, what is this atom, what is this quantum mechanics. They had no idea about this, but in this lecture we are going to link upon these two things. But at that point they had no idea about that actually what is the structure of atom, how does it look like. They had no idea about this, right? Okay. However, the beginning of 20th century witnessed profound developments in theories about subatomic particles. Now, very, very important line. If they ask you, Mendeleev, he was very keen, interested in the empirical formulas, right? And this one, this Henry, after the Henry Moseley, what exactly he did? He just made a graph. Okay, what kind of graph he made? What kind of graph he made? He made a graph between frequency, under root of frequency, and the atomic number. Now, this was the first time that somebody talked about atomic number, not the atomic masses, right? What he observed that with atomic number, there was a straight line. But with atomic masses, there was not a straight line. Straight line means with increase in atomic number, the frequency is increasing. That means it is the periodic function. It is increasing at regular intervals, right? So now, he took advantage of this thing, right? He said, okay, this is what I have discovered. Now, let's tell this to the other scientist. Henry Moseley, the name was Henry Moseley, right? The graph was frequency and atomic number. Lothar Meyer, the graph was atomic volume, boiling point. Basically, they talk about atomic volume only. But yeah, boiling point, melting point graph is not that much famous. Atomic volume graph is famous, right? The graph was between atomic volume and atomic weight. Here, the graph is between frequency and atomic number. Okay, so don't get confused here. Observe regularities in the characteristics X spectra of the elements. A plot mu where mu is the frequency of X-rays. Now this is important, frequencies of X-rays, right, against atomic number, that is atomic number denoted by Z, gave a straight line, not the graph of frequency and the atomic mass. He concluded that atomic number is more fundamental property. He said that why we are talking about this atomic weight, why are you not talking about atomic number? That is a better fundamental quantity to discuss about. That will give us a better, that was a, like, you know, that was an exceptional thing that he gave the scientists to think upon. And based on that thing, we have modern periodic table, right? Still we follow modern periodic table, right? And this table has made studying the chemistry so easy, right? You find it a little bit difficult, but just imagine, if there is no modern periodic table, how will you even learn these elements? There will be no mnemonics, there will be no symmetry. That means you will just go mad. This will be most difficult subject, right? Even tough than physics. How? When you don't know, there is some classification. Now you know the classification. That's why you are able to learn this with the help of mnemonics. You're able to understand the property with increasing and the decreasing trend. That is how chemistry, inorganic chemistry becomes slightly easier for you, right? So you should thank him. Now, and not the between this and this, he said he thereby showed that atomic number is more fundamental property of an element than the atomic masses. Mendeleev periodic law was therefore accordingly modified, right? So that was called as modern periodic law. So what was this modern periodic law? That was, wait, have I not written it somewhere? Yeah, I have written it. It's here. Okay. The physical and the chemical. He also specified the physical and the chemical properties here. He said it is a periodic function of their atomic numbers, not the atomic masses. Simple thing he told us here. Now, the periodic law revealed, now very important thing, what it revealed. The periodic law revealed important analogies among 94 naturally occurring elements. Very, very important, mark this, very important, right? He discovered that there was something, these elements were actually interrelated to each other. What he exactly said, because this example is mentioned in your NCERT. That is why it becomes easy. You don't have to remember all the examples here. You have to remember the examples that is there in your NCERT. So it is there in the NCERT. He is saying neptunium and plutonium, like actinium and proactinium. He said neptunium and plutonium, they are also found in the pitch blend. That is an ore of uranium. Very, very important. Very, very important. Mark this. You can see a question from this. Mark it important. Mark it important, direct question. And most of the students who have not, who have not given a single reading to this NCERT, they won't be able to answer this. I can guarantee that, right? Because that is a different kind of example. They're talking about ore, that okay, this was something that they discovered because of this periodic classification. It helped them in all of these things, right? So chemistry has carried into, okay, so what this thing? It stimulated renewed interest of inorganic chemistry and has carried out in the present with the creation of artificially produced short-lived elements, right? They are basically talking about radioactive elements, right? So basically what they are talking about, radioactive elements. Now, you may recall the atomic number is equals to nuclear charge. Now they will relate the structure of atom with the periodic table, right? Now let us see. They are saying the atomic number is basically what? The nuclear charge. In the nucleus you have protons, you have neutrons. Neutrons These are electrons, these are neutrons. These protons are going to, because the proton is positive, it is going to attract the electron towards itself. That is the nuclear charge, right? Except for the minus the shielding effect, it is going to attract it, right? So what is going to happen here? He is saying it is then easy to visualize the significance of quantum number. He said that you are talking about S, P, D, F. What are all these? These all are the orbitals, right? These are where you write the electronic configuration. And in the same way, you will have the periodic table, that is S block, P block, D block and F block. This is what they are showing in this, all of this thing. In fact, it is now recognized that periodic law is essentially the consequence of periodic variation with electronic configuration. I told you now, electronic configuration 1s to 2s to 2p. And periodic is also SP. You will see the periodic table is also like that. Right? So basically the electronic configuration is based on the electronic configuration is based on the periodic table only. Right? So this is S. That is why you write S2. Right? That is why you have S2. Why you write it S2? Because it is two groups in S block. Right? So in S orbital, you have 2 electrons maximum, right? In D, this is the D block. D block is like this, right? And you have total 10 electrons, and here you have 10 groups. In P, you write it as 3 boxes, 6 electrons, maximum 6 electrons can be there. 1, 2, 3, 4, 5, 6. 6 groups are there, right? Similarly with F block, that means F14. Why F14? Because maximum you can have 14 electrons in F block, right? You have 14 elements in F block, right? In one, you have here in lanthanoids, you have 14. Actinoids, you have 14. So that means these all are interrelated to each other. They are not like separated. Though the structure of atom was discovered after this, but yeah, the studies were going simultaneously. It's not like, okay, I'll do this only, I'll do that only. The studies, somebody was discovering the structure of atoms, somebody was doing studies on these periodic elements. So it was going simultaneously, okay. So now let us see. Wait. Bacha, till now any problem? Till now any problem in anything? If you have any problem in anything, then please write it down in the chat box. Any problem? Any problem, bachcho? If you have any problem, write it down, because let us now start with this thing. Are you able to see this? No? No, ma'am. Oof. Ma'am has to set the camera. I think now you are able to see this. I'll have to set the camera because I was not there in the studio. I was not there in the studio for like 3-4 days, no? So, ghar wale, dude, ghar wale, right? So, ghar wale must be doing some safai kind of thing. They must be, cleaning the room, and just camera got little bit here and there, right? Okay? Yes. Chalo. Now, numerous forms of periodic table have been devised from time to time, but the most adapted form is modern periodic table. Some form emphasize chemical reactions and valence, whereas others stress on electronic configuration. A modern table, that is the long form of periodic table, is the most convenient and widely used, right? Most convenient that we actually see. In today's life, we only talk about modern periodic table, right? So that is basically based on, he's saying that in Mendeleev periodic table, you had horizontal rows that were called series, but here it is, he called it periods, and in the bracket what they have written, Mendeleev called series. That means Mendeleev called the horizontal rows as series, but he called the horizontal rows as periods. Okay, he called the horizontal rows as periods. Now the vertical columns, both by Mendeleev and by him also, they were called as groups, right? Elements having similar outer electronic configuration in their atoms arranged in vertical columns. Now, ma'am, what they are saying. Now, what if you talk about group number 1? This is your group number 1. This is your group number 2. In group number 1, you will have elements of 1s1. In group number 2, you will have elements of 1s2. That means what he is saying, elements having similar outer electronic configuration. That means the outer electronic configuration must be same. Now this S1, that means all the elements in the group number 1 is going to have S1 electrons. All the elements in group number 2 is going to have S2 electrons. Right? That will be the electronic configuration. Now, elements having similar outer electronic configuration in their atoms are arranged in vertical columns, referred as groups or families. They were also called as families, right? Now, because they belong to the same setup, the outermost configuration was same only, right? So, they were also called as families, oxygen family, halogen family, right? According to the recommendation of International IUPAC, it is said that the groups are numbered from 1 to 18, replace the older notation of 1A, 1B, all of these. Now, what is that? Mendeleev periodic table said that you have, write it down here, Mendeleev. Write down Mendeleev. Mendeleev said this is modern. This is modern, right? In Mendeleev, he said that the group is going to be, he said that the group is going to be 8 groups, right? And that will be A and B. But here he said that it will be 1 to 18 groups, right? He said that the periods, or you can say he said that the series is going to be how many? 7. He said that the periods is going to be how many? 7. So that was the crux of Mendeleev and modern periodic table, the little bit differences of this, right? Okay. Now, next is according to this is, so they named 1A to 8, or this 1A, 8B, all of these ABC division onto that. He said that that will be 1 to 18 itself, right? He's like, no more complication here, because that was a little bit complicated, like remembering this is 1A, this is 1B, and there were also so many things that were actually against the Mendeleev periodic law, right? So that was the difference. Then there are altogether 7 periods. He said that there are 7 periods. Oh my God. There are 7 periods. He said that there are altogether 7 periods. 7 periods. Period number correspond to highest. Now what he is saying? He is saying that always remember. He is saying that the period number is nothing but that is the largest value of principal quantum number. If you have a configuration 1s2, 2s2, 2p3, the largest value is 2. That means it is going to belong to the second period. This belongs to the second period. If you have a configuration like this 1s2, 2s2, 2p6, 3s2, the largest value is 3. The largest value of principal quantum number is 3. So it is belonging to the third period, right? It is belonging to the third period. Now this was what they are saying in this line, okay? Hanji bachcho, okay na? Chal. Now just write it down here. Highest principal quantum number of the elements is the period. The first period contains 2 elements. Now what is this? Basically they are talking about the magic numbers, right? That is why I am here. When you read it yourself, you just skip all of these lines. Okay, this is saying this. You have to decode NCERT. Every single line of NCERT has something important in it. Something important is hidden there, right? So you have to remember that. Now basically he is talking about magic numbers, right? Magic numbers is 2, 8, 8, 18, 18, 32, 32. Right? So what he is saying, the subsequent period of this is 2, 8, 8, 18, 18, 32, 32. Now basically if you add on to these things, This is your 2. This is 2 plus 8, that is 10. This is 10 plus 8, that is 18. 18 plus 18, that is 36. 36 plus 18, 36, I think 54, right? That will be 54, right? 54 plus 32, that will be 86, right? Now what are these? What are these? 2, 10, 18, 36, 54, 86. What are these? These are the noble gases. These are the noble gases. These are the noble gases. Now, why these are called the magic numbers? Why they are called the magic number? I will show you that in the table itself. Okay, we'll see the table and we'll see why these are called the magic numbers. Now, you see the table here. You see the table here. Okay, ma'am, let us talk about this. Let us talk about this boron. Let us talk about this. Okay, so let us talk about this. This only. Noble gases. Now, it has an atomic number of 2, right? This is 18, this is 10, this is 10, this is 18, that is 36, that is 54, 86, right? Okay, so these are the atomic numbers here. And you also need to remember the atomic numbers of the the noble gases. Very, very important, right? Now, what they actually saw, the magic numbers 2, 8, 18, 18, 32, 32. Firstly, though, we need to find out why there are these many elements here. So, firstly, though, let us talk about the first period here. In the first period, you have hydrogen and helium. That means you have 2 elements here. In the second period, you have 2 plus 6. That is 8. In the third period, you have 2 plus 10 plus this. So, in total, you will have 18 elements because here you have this one, and this one, right? So, that is 2 plus 10 plus 6, that is 18. In the fifth period, so sorry, 1, 2, 3. In the fourth period, you have these 2, right? Array. The first one should be here. It should be here. It should be. Wait. So there is 2. This is 6 plus 2. Yeah, that is 8 elements only, right? And what about this one? This is also 8 elements. Yeah. This is also, basically, this is also 8 elements. This is 2 and this is 6. So that is also 8 elements. What about the fourth period? This is 2 and this is 10 plus this is 6. That is the 18 elements. What about the fifth period? What about the fifth period? How many elements are there? Tell me the number of elements in the fifth period. Tell me the number of elements in the fifth period. In the fifth period, you have 2 plus 10 plus 6. 2 plus 10 plus 6, again it is 18, right? Now what about this one? Here there is some kind of ghapla. What is that? From here, from this part, and this part, you have there is some kind of F block elements are hidden here. Okay, from here you have lanthanoids, from here you have actinoids. It is 14, it is 14. So it will be 2 plus 14 and 10 elements of D block, and bacha you have 6 elements of P block. Total it will be 24, 26 plus 6, that is 32. So here it will be 32 elements. Similarly with 7th period it will be 32. So basically magic numbers are the number of elements, right? These are the number of elements in each period 1 to 7, right? That is the number of elements in each period, that is 1 to 7. Is that clear to everybody? Now you tell me why they are called the magic numbers. 2, 8, 8, 18, 18, 32, 32. Why they are called? This is first, second, third, fourth, fifth, sixth, 7th period, right? And the 7th period was, for most of the time it was uncompleted, not completed, right? Some of the elements were missing, but now it is getting completed, right? So now why it is called magic number? It is going to do some kind of magic. It is going to clear your NEET by studying only 2 chapters, right? Some kind of like that kind of magic? No, nothing like that is going to happen here. They are called the magic numbers because when we add them, we get the atomic number for the next period. For example, this is titanium, this is 22, right? This is 22. I want to know the atomic number of zirconium, right? So I will add this here. Okay, I will add this here. This is 2, 2, 8, 8, 18, 18, 32, 32. So I will add what here? I will add 18 here. 18 means I will add these elements, 10 elements here, 6 elements of that, 2 elements of that. So I will add 22 plus 18. 22 plus 18 is going to be 0, 40. So that will be basically 40, right? Okay. So that means by knowing the atomic number, for example, scandium. Scandium is 21. I want to know the atomic number of this. Now, what about the atomic number of this ytterbium? How do I know the atomic number of ytterbium? I will add 21 plus 18. That is 9, 2, 3, 39. Okay, right? Understood? That is why they are called the magic numbers, because you know the atomic number of even one element of that group, you can know the atomic number of other elements of that group also. How? Just by adding the magic numbers. Okay? Yes? Okay, bacha? That is why they were called the magic numbers. Now, let us talk about the nomenclature here, right? So, that thing that was done here. Chalo. So, the 7th period is incomplete. As I told you, that was incomplete. Like the 6th period would have theoretically maximum this. It will also have 32 elements. In the form of periodic table, 14 elements of both 6th and 7th period, they were taken out as F block, that is lengthenoids and the actinoids separately, right? And they are separately placed down the group. Okay. What about this one? Nomenclature, beta, you don't have to read all of this. You don't have to read all of this. You just see the summary here. What exactly happened at that point? Some scientists, I will tell you the name of the scientist also. Okay. So what exactly happened? Both American and Soviet scientists were doing experiments, right? And they were discovering the elements there. Both of them discovered. Now what exactly happened? They started fighting. Okay, I discovered this. This should be on the name of our country. This should be on the name of our country. This should be on the name of our scientist. Okay, so these kind of things were going on here. So what exactly happened here? Because these kind of things were going here, that is the reason, okay, that is the reason these things, okay, they have to make something out of this. They have to make a rule out of this, right? They said, okay, till the time we understand that exactly who discovered, there are proper proofs of who discovered this element, so that we can give a name on the basis of scientists or the countries, right? We will have a nomenclature of that. And the nomenclature was very simple. The nomenclature was for 0 you have nil, 1 you have un, 2 bi, 3 tri, quad, pent, hex, sept, oct, n, right? And these were the symbol. And at the end you will have IUM, right? In the end you have a very simple thing that will be IUM. Now what does that mean? This is what it means, right? As you can see here, bacha. So this is your 101. Everybody, this is the favorite task of students, right? They enjoy this. They are like completely fan of this. Yes, bacha, Devesh, Pavitra, Criminal Gaming, Nancy, Divya, Soni Mohan, Sarayana. Then we have Soni Mohan. Then who else? Yes, everybody. Your name here, I'll announce. Okay, Naina, Harborain. Then we have Mohit, Anji. Then we have Rajendra, Muruga. Chalo, Rudra. Very good, very good. Chalo, I am so happy that you guys are actually studying here. Now you tell me the names here. The names of this 103. Why? 1 means un, 0 means nil, 3 3 means try. So it will be unnil trium. So what about this 107? Unnil septium. What about this 109? Unnil 9 is inium. So unnil inium. What about 111? What about 111? That will be unium. Okay. 114. Quadium. Quad for 4. Right? So that is the how you will answer the names. That is so very simple. But in just past 2 years, like in 2023 and I guess 2020, they asked questions based on these difficult names, right? So I'll just tell you whatever the names that are actually important for you. If you ask me, ma'am, do I need to learn all of this? If you have, you must. It's not necessary that they will ask this, but yeah, if you don't want to take any risk, you want to have 720 out of 720, then yes, you must learn this also, right? So basically, this was also given in PYQ, right? Then Mendeleev's is also very important. Then you should know Darmat stadium also, very, very important. Then bacha, you have question was based on Rotengium. Yes. Rotengium, yes. So these are basically 4 or 5 that are very, very important, right? That are very, very important. Okay? Okay, bacho? Chalo. Now, next is, does the new element first gets a temporary name with symbol consisting of 3 letters? That was the temporary name that was given to them. Later, permanent names were given and symbols are given by a vote of IUPSC representative that, okay, there were fight going on, then okay, they said actually this person discovered this, so the name should be based on this scientist only, or the country, right, or the state in which element was discovered, or pay tribute to the notable scientist, right? So that was the theory, that was the story behind that, right? Why they need to make all of these things, right? That was the simple story behind that. Now, bacha, let's discuss about the electronic configuration and the shell here, right? So in the preceding unit, this is, you don't need to understand that. First thing is the principal quantum number. We know that represents the shell, right? That is n. We also know now what they are actually telling you here, just recalling that thing here. N tells you the shell. They are saying L tells you the subshell. They are saying then M, that tells you the orbitals. This is what they are saying. This is what they are saying here. We have also studied about the filling of electrons into different subshells, also referred to as orbitals. Now students actually get confused. They're like, okay ma'am, subshells are called orbitals. Okay. Students misunderstood these things because decoding NCERT is also a task, right? They think, okay, subshells are orbitals, subshells are L, these are the orbitals, right? So basically what they are saying is, they are simply saying this thing only, that you have a subshell P. This is the P subshell and you have 3 orbitals, that is Px, Py and Pz. And you fill the electrons this way and you fill the electrons this way. He said that it has some relation with the periodic classification also, right? So what he said that because you're filling 6 electrons in this orbital, that is why you have 6 here, right? Similarly, we have 6 groups over here, right? This is what they are saying, as element location in the periodic table reflects the quantum number in the last orbital. In this section, we will observe direct connection between electronic configuration and the long form of periodic table. So that is the direct relation, right? So firstly, we will talk about the periods. Periods, so I told you directly how you find the period number. Everybody in the chat box, how you find the period number? That is the largest value of n in, or you can say largest value of principal. Write it down in the NCERT. Why I am writing it here? Because I want all of you to write it down in the NCERT. Make your short notes here. Write it down. Largest value of principal quantum number is the period number whenever electronic configuration is given to you. So what they are saying, the period indicates the value of n for the outermost. This is, in other words, successive period in the this is associated with filling of next higher level. ma'am, what is this? Basically, they are asking that, okay, this is 1, this is 2, this is 3, this is 4. Here it will be filling will be 1s. Maybe if I talk about first group, it will be 1s1. In the second group, it will be 2s1. Third group, it will be 3s1. Sorry, third period, not group. This is one group. Because the group is same, when the group is same, the number of outermost electrons is same, but the principal quantum number is not same. So first period you have 1s1, second you have 2s1, third you have 3s1, fourth you have 4s1, and so on it will go. 5 will have 5s1, 6 will have 6s1, 7 will have 7s1, right? Like that it will be. Okay? Yes? It can be readily seen that number of elements in each period is twice the number of orbitals available in the energy that is being filled. Now, ma'am, what this is saying? Because this part is little tricky, okay? So, what it is saying? It is being readily seen that number of elements in each period. First period you have 2 elements, right? Second period you have 8 elements. Why? Because in the first you have 1s2. In this you have 1s2, 2s2, 2p6. So basically the outermost electrons are 2. The outermost electrons are 8. So this is what they are saying, right? This is what they are saying here. The number of elements of each period is twice the number of atomic orbitals. That means the electrons they are talking about, right? This is what I have already told you that, okay, if you have p orbital, you have 6 electrons here. That is twice the number of orbitals. Orbitals are 3, electrons are 6, and in p block you have 6 elements. This is what they are saying, right? Okay, so I think that is clear to everyone here. Now just underline this thing. They can give you exact line here. So I'll write the simpler version of this line over here. You also write the simpler version. We are talking about decoding NCERT, right? So write the simpler version here that p orbital has 6, right? S has 2, D has 10, electron, 6 elements. Or you can also write it in this way. 2 into 3. This is 2 into 1. 1 is the orbital number. D has 5 orbitals. So this is into 2. So this is basically 2. This is basically 10. So these are this many elements. Right? Also with F. F has 7 orbitals. Right? So 14 elements. Okay? So it has 14 elements. Right, bacha? It has 14 elements. Now, everybody, beta, be active in the chats also, be active. Are you also writing it down in your NCERTs? Are you writing it down in your NCERTs? Right? Why so much hard work we are doing for you here? Because we want you to go through each and every line of NCERT here. So, everybody, if you are writing it down in your NCERT, I want all of you to mark this tick button here. This green tick button is there in your emojis now. So just this green tick button here if you are actually writing it down in your NCERT. If not, I want this cross button here in the chat box, right? I want that cross button. Those who are not writing it down and those who are writing it down, I want green button. Okay. The first element, the first period n is equals to 1 starts with filling of lowest energy level, that is 1s1. Now this is also very, very important. Right, lowest energy level, that is 1s1. Therefore, two elements, hydrogen and helium. Now, he is saying the first period has the filling of 1s orbital. First will be first electron and then will be second electron. The number of electrons is the number of elements. Right, so that is why it has 2 electrons. The second orbital has 2s2, 2p6, and that is why it has 8 electrons. Right, and that is why it has 8 electrons. Now what he is saying, the period number 2 starts with the lithium and third electron enters the 2s orbital. Then it goes to beryllium. Then beryllium has 1s2, 2s2 and so on. It fills all the electrons here, that is 2s2, 2p6. Basically what happens exactly, beta? What exactly happens here? From the second period, it is firstly it is 2s it is basically 2s1, then it is 2s2, then it is 2s2 2p1, then it is 2s2 outermost I am saying. So it is 2s2 2p3, then it is 2s2 2p4, then it is 2s2 2p5, the last it is 2s2 2p6. That means this is what we are doing here. 1, 2, 3, then 4, then 5, this is 6. 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 elements that are filled here, right? So that is why it has 8 elements, and this is the electronic configuration of the last element, that is the neon. Okay? Yes, bacha? Okay, ji? Chalo. Next, beta, we have this thing. Then, beta, let's talk about here. You will have some exceptions. 8 elements in the second period. The third period, beta, again, third period has 3s, 3p, and 3d. Okay? So now, more simpler version of this. 3s, what you have? You have 3s, you have 3s, you have 3p, you have 3d. How many electrons? 2 it has, 6 it has 10. So total it will be 18 electrons. So that is why it has total of 18 electrons over here, right? So just write it down that okay, it will have total of 18 electrons. This is what they have mentioned here. Successively the electrons in 3s and 3p will be filled. After that they will be filling in the 3d orbitals, right? Okay. Okay, beta, becomes energy favorable. We came to across the called, okay. So now what they are talking about the 3D elements here. What they are talking about these 3D elements. They are saying these 3D elements are called the transition elements. Because here you have S block is very highly reactive. P block is very less reactive. So there is transition from metallic to non-metallic. From more reactive to less reactive. Right, so that is called the transition elements, right? These are called the transition elements. We have a dedicated chapter for this. That is your DNF block. So we will study that in DNF block, right? This starts from scandium. This starts from atomic number 21, right? This is the 3D series and it ends with zinc here, very important, with electronic configuration of this. The fourth period ends at krypton with the filling of this 4p orbitals. Okay, then bacha, the 4D transition series start at ytterbium. Write it down. That is atomic number 39. We can also do that with the help of simple magic numbers, right? The period ends at xenon. Now they are talking about this period ends at xenon, right? Next is 6th period. In 6th period, you have 6s, you have 4f also, 5d also, 6p also, right? So many things you have here, right? You have these orbitals. In the order filling up of 4f begins with this is this. Now what they are saying, the F4f orbital that start with very, very important, that is 58, that is cerium, and it ends at 71, that is lutetium. Very, very important. These are called the inner transition elements. You have to remember from where it starts, from where it ends, right? These are the lanthanoids that starts from 58 to 71, right? Lanthanum is also included in 4f only, but that belongs to group number 3. All the lanthanoids and actinoids belongs to group number 3 only, right? So the 7th period is similar to 6th period. Now they are saying that is similar to the 6th period only. That means it has 7s, 5f, 6d, 7p orbitals, includes most man-made, very important. Actinoids they are talking about. Actinoids are radioactive elements, right? Very short-lived elements. So they are saying the period will end at the element with atomic number 118, that is which would belong to the noble gas family. This is yet to discover. We have 114 elements. This 118 element, they are saying the period is going to end at that. It is yet to discover. Still we have so many elements, 3-4 elements that we are yet to discover. Scientists are doing that. Filling up 5f orbital after actinium, that is actinium is atomic number 89, gives 5f inner transition series known as actinoid series. The 4f and 5f inner transition, 2 transition series, that is under the F blocks, 4f and 5f, right? Now they are saying separately in product to maintain its structure and preserve the principle of the classification by keeping elements in similar properties of the single. Basically they are saying that okay, that is why periodic table was made this way. Yes, it has a direct relation with the electronic configuration, right? Then they are saying elements in the same vertical column, vertical means these columns, have similar valence shell electronic configuration. Now this is very important. For that, to make it very simple for you, I have already told you this very simple thing. If they ask you about the group BG means firstly find the block. From the electronic configuration, find the block. This is what they are saying in these hi-fi lines. This is what they are saying. Find the block firstly, and after that find the group. If that is a S block, it will be number of electrons in NS2 shell, right? In NS2, the number of electrons in that, right? The number of, it has, I would say, in NS, not NS2, in NS. Why? It can have 1, it can have 2 electron. If it is 1 electron, it is belonging to group number 1. 2 electron belonging to group number 2, right? Second, if it has D, if it belongs to D block, then it will be 2 plus number of electrons in N minus D, N minus 1D subshell. The number of electrons in N minus 1D subshell plus 2. That 2 is for the S block, because when you see the periodic table, it's like this. When you're talking about D block, 2 electrons are already filled up here. So when you're adding the D block, so 2 electrons, these will be calculated here. When you're talking about the P block, the electrons of D are calculated here, right? So for P, you have 12 plus number of electrons in NP subshell. Number of electrons in NP subshell, right? And F, you don't have to do that, okay? F is not, because that is a completely different thing, right? F is just lanthanoids and actinoids. You have to remember the atomic numbers for that. You have to remember the atomic numbers for lanthanoids and actinoids. This is from 57 to 71, and it is from 89 to, it will end at 118. Okay, you have to remember that. Okay, bacha? So there can be only 3 things here. Thank you so much, bacha. Thank you so much. Okay, done. Now, next part is, I think that is also done. The similar number of electrons in the outer orbitals. So what they are saying, have similar shell electronic configuration. What they are saying, it will have, for example, the group number 2 will always have NS2, right? So this is what they are saying, outermost electronic configuration will be similar. The same number of electrons in the outer orbitals and similar properties. For example, group number 1 will always have NS1. Thus, it can be seen that properties of elements having periodic dependence upon its atomic number, not on the atomic masses. Okay, so groups are based on the atomic number. That is why the periodicity is based on the atomic numbers here. Now, bacha, as you can see here, this is your atomic number, right? And this is your symbol is given. This is basically group number 1, right? So basically, here we have group number 1. Group number 1 is given to you. Atomic numbers is given to you. You can see 3 plus 8, 8, 9, 10, 11, right? Then again you have 8, then you have 18, then you have 18, then you have 32, right? 55 plus 32, that is 7, 8. That means you can calculate with the help of magic number. Any atomic number can be calculated for a particular group. For one group, any atomic number can be calculated. First thing that we observed here. Second is what we observed here. The last outermost configuration was NS1. The configuration is NS1. Though N is different. N is different because principal quantum number is different. It belongs to because it is 2, it belongs to second period, it belongs to third period, it belongs to fourth period, it belongs to fifth period, it belongs to sixth period, right? It belongs to seventh period. That is why n is different, right? So basically, principal quantum number, period. Group means outermost shell configuration. Clear, bacha? Block, so you can see block means, how do you calculate the block? The last electron is there in which subshell, that is the block, right? That is the block. Okay, bacha? Now almost we are heading toward the end of this, not this chapter, but today's lecture. So I will need one more lecture that we will discuss about the trends in the product table in that lecture, right? That only you can understand if you have already done this thing. Now they are talking about the electronic configuration of SPDF block, but they are saying a theoretical foundation, the elements in the vertical column of this constitute a group or family and exhibit similar chemical behavior. In groups, they have similar chemical behavior. This similarity arises because of these elements have same number, same distribution of electrons in the outermost orbitals. Assertion, reasoning question directly. Simple assertion, reasoning question. Students will do mistake here, silly mistakes here. What they will ask you, why the properties are similar? Some random answers will be there, right? But the correct answer will be because of the outermost electrons are same, right? We can classify elements into 4 blocks, SPDF, depending on the atomic orbitals in which they are filled in. The last electron in filled in which subshell, that defines the block. Okay, that defines the block. We notice 2 exceptions to this. Now this is very, very important. Whenever you see NCERT saying, when NCERT itself is saying na there is exception, then okay, let's focus here. Now this whole thing will be highlighted, okay, because NCERT itself is saying you have some exception here. What they are saying, 2 exceptions. Strictly, helium belongs to the S block. Very important line, see this. Just don't see the, okay, helium and hydrogen are exceptions. Why? Reason, assertion, reason, statement based questions. Right from inorganic, you can see that. Strictly, helium belongs to, which it belongs to S block. Right? But why helium belongs to S block? Because bacha, helium has electronic configuration 1s2, 2s2. The last electron is in the S orbital. That means it should be S block, but it is not S block. It is not S block. It is not S block. But its positioning in the P block along with other group number 18 elements is justified because helium has fully filled duplet here, right? It behaves as a noble gas, right? So, but here with this rule that, okay, the last electron, where the last electron, that is the block, it is exception to that rule, right? So, it completely filled valence electron and as a result exhibit properties, characteristics of other noble gases. Next is, the other exception is hydrogen. Hydrogen, why? The reason is it is only one S electron. Only one S electron. It can gain the electron, it can lose the electron. If it gains the electron, it will behave as a halogen. Group number 17. Group number 17 says that, okay, we have PS5, this is S. So what we will do, we will gain one electron and we will become S2P6. So that means gaining the electron means becoming like halogen. Losing the electron means becoming like group number 1, that is alkali metal. So now they are very confused. Either it can do like this or it can lose electron and become, right? So now, but this hydrogen still have this anomalous position. Still its position is not justified. It is still in the exception. Right, the biggest failure of modern periodic table is the position of halogen only, right? That is the biggest failure. So, group number 1, it is placed in group number 1, that is alkali metals. It can also gain one electron to achieve noble gas arrangement and it behaves as a group number 17 halogen family, right? So, it is behaving as both alkali and halogen family because it is special case. We shall place hydrogen separately in the top position. Okay, so what they are saying, we have placed it here, we have placed it separately here. But in most of the periodic in NCERT, they have placed it here. So for you, it is here. But in some books, it is also placed here. And that is not wrong. Okay. It is never placed here. In some books, it is placed here. In some, the most accurate thing is placing it here. But in some books, it is also placed here. But you have to remember the NCERT thing. Right? Okay, bacha? Chalo. Now, because it is special case, okay, this too we have done, we will briefly discuss the salient features of 4 type, more about these elements, this. Now let us go and discuss that. The S block, we have to discuss these 4 blocks here. Let us discuss that. S block. S block means 2 elements. Everybody along with me. S block. S block means 2 groups here. Group number 1, alkali. Group number 2, alkaline earth metals. Alkali metals is, this is group number 1, alkali. This is alkaline earth metal. Okay, this is Leena ki Ruby se friendship. Right, Leena ki Ruby se friendship. Lithium. What you can see here, Leena ki Ruby se friendship. Okay. I will also give you other mnemonics for that in the next class. Leena ki Ruby se friendship. Right, this is group number 1. Group number 2 is बेटा मांगे कार स्कूटर, बेटा मांगे कार स्कूटर, बाप रोए, बाप राजी. Okay, बाप राजी. And most of these last period, the elements belonging to last periods are mostly radioactive in nature. Okay, so let us see what about these elements, what they are saying. They are saying that group number 1 is alkali metals and group number 2 is alkaline earth metals, which have NS1, NS2 configurations, right? Then they are saying they are very reactive metals, right? They will easily, they're very electropositive. They will lose electron and become stable. Everybody in this world wants to become stable, want to have a stable electronic configuration, right? With low ionization enthalpies. Very, very important. Write it here. Now, in the next 3 pages, I am going to underline the very, very most important lines from these 4 blocks. So everybody take out your pen and underline that with me. They have low ionization enthalpies. They lose the outermost electron readily to form +1 ion here and +2 for alkaline earth metals, right? The metallic character and the reactivity increases as we go down the group. I will also tell you the reason behind that in the trends, okay, that we will do in the next class. Because of high reactivity, they are never found in pure state. Very, very, very important. Okay, I would like to write it with some other pen. Because of high reactivity, they are never found in pure state. Very reactive, they will found as a ore, right? Something like that. The compounds of S block elements, with exception, very important line again, a very important line. The compounds of S block elements are ionic with the exception of lithium and beryllium. They are saying lithium compounds and beryllium compounds are covalent, but other compounds of S block are predominantly ionic in nature. So what is the compounds of S block elements, with exceptions of those of lithium and beryllium, are predominantly ionic in nature, right? Very, very important. Whatever I am underlining in some different kind of pen, that is most important thing. Okay, that is most important thing. Next is, bacha, the P block elements comprise those belonging to group number 13 and 18, right? This, so we also have a separate chapter based on this, right? That is in your old NCERT. I really hope in 2025, in this year, the NCERT that is published, they have this, right? But in the last NCERT, P block was not there, but that was there in the exam. That was there in the syllabus of NEET, right? So group number 13 to 18 elements belongs to the P block, right? Then, bacha, what about the other thing that belongs to the P block? Then we have the S block elements are called, very important thing, bacha, S block elements with, that means S block elements plus P block elements are called the representative elements. What are these called, everybody? representative elements or the main group elements, right? S and P. Okay, what are these? These are basically S plus P. These are the representative elements, right? Then bacha, next is the outermost electronic configuration is NS2, NP1 to NS2, NP6, right? That's why it has 6 blocks here. It also has noble gases, right? So at the end of each period, the noble gas element with a closed valency, this begins except for helium that has only NS2, right? All the orbitals in the valence shell of noble gas are completely filled, right, by electrons. It is very difficult to alter this stable arrangement by the addition or the removal of electrons. They are talking about noble gases. You can't alter the electronic configuration. That is why they are called noble gases, the Sant Mahatma, right? They are very stable, very happy. Now the noble gases thus exhibit very low chemical, very important. They exhibit low chemical reactivity. Preceding the noble gases families, other two important families that we talk about, other two important families are the halogens and the chalcogens. What are these halogens? They are basically the group number 17 elements. What are these chalcogens? They are the oxygen family, right? That is a group number 16. What do you write here? Write down in your NCERT, write down an oxygen family. Oxygen family. Okay. Then bacha, next is these two group of elements have highly negative electron gain enthalpy. Very important again. They have highly negative electron gain enthalpy. Very negative electron gain enthalpy they have, and readily add 1. Now beta, what is this electron gain enthalpy? I will tell you that, but for now you just understand that electron gain enthalpy means when you want to add the electron, right? If the atom is very happy that okay, you gave me the electron, I am very happy. So what it will do? It will release the energy. When you are very hungry and somebody gives you your favorite food, you will say, yay, I am very happy, right? I am very hungry. Okay, please give me some dosa. So you will be very happy after that. Yes, now I am very happy. I am happy in life. My plate is full. My stomach is full, right? So this is what happens with the elements also. When they are hungry, right? When they are hungry and when the need is justified, fulfilled, then they release the energy. And because these chalcogens and halogens, it needs 1 electron, it needs 2 electrons to get into noble gas configuration. And that is why they have very highly negative electron gain enthalpies and readily add 1 or 2 electrons respectively to attain noble gas configuration. Then bacha, the non-metallic character increases from here to here, from S to P. The non-metallic, again those students who are confused in trends, but a dedicated lecture in the next class will be based on trends from NCERT, right? From exactly your NCERT book, I will pick up those, right? Even now you see your NCERT, I have not skipped even a single line, right? So from left to right across the period, metallic character increases as we go down the group. Here beta, non-metallic, down the group metallic, okay? So now important thing here is, then bacha, you have D block elements. For D block elements, we have a dedicated chapter for that. So you just need to remember that, okay, usually the electronic configuration is N-1D, 1 to 10, or you can just write it here. I'll do the, okay, I will not do because this is the NCERT book only. Let's not criticize the NCERT book. Okay, so this is the general electronic configuration, that is right. But except for PD, they should not have written except for PD, because if they have written NS 0 to 2, that means they have included PD here, right? So basically that means PD has S orbital which has 0 electrons, right? So this is a very, very important electronic configuration that we are going to do in D blocks as well. Okay, we will do that in detail. Now there are some properties for these D blocks, very, very important. That is why they are very famous. First of all, they are all metals. They formed color ions. They have variable oxidation states. Then bacha, they are paramagnetic. They are colored compounds used as catalyst. They have interhalogen compounds. However, zinc, now this zinc, cadmium and mercury, they are non-transition elements. This is also the question from D block. Why? Because transition means the d orbital should not be fully filled. But for zinc, cadmium and mercury, it has this kind of electronic configuration where the d orbital is fully filled. When the d orbital is fully filled in D block, they are non-transition elements, right? And that should be in the excited state, not in the ground state. Even in the excited state, they should have D10. Otherwise, so silver also have D10, right? But in the excited state, it does not have D10, right? So do not exist most of the properties of transition. This way, transition metals bridge between chemically active S block and the less active group number 13. They are called the transition elements. And the last thing of today, that is your 2 rows, that is inner transition elements. First is lanthanoids that starts from 58 to 71, right? Actinoids that starts from 90 to 103. Okay, others are yet to discover. Then bacha, you have are characterized by the outer electronic configuration, that is this, right? This is the outermost electronic configuration. You will see, ma'am, why you are not doing this in detail. The reason is, this is again in DNF block. We will do the exceptional electronic configuration. I would not advise you to do the electronic configuration here, because I will tell you the direct electronic configuration in F block. So wait for that, okay? Just wait for that thing, right? But still, if you want to underline, this is the important part here. The last electron is added to the F orbital. The 2 series are called inner transition elements, right? They are all metals within each series, and in actinoids you have radioactive elements, right? They are all metals. With each series, the properties of elements are quite similar. The chemistry of the early actinoids is more complicated. That is why that is not that much detail in your syllabus, skipped in your syllabus, due to large number of oxidation states possible for these actinoid elements. Now underline this point. Everybody, question again here. The chemistry of actinoids is complicated than this, due to, when you have due to in the question itself, that means you have assertion reasoning question here. Mark it assertion reasoning question here, okay? That is why I have underlined that point there. So now this is the assertion reasoning question that you have here. Now just mark it here that why this is important, because due to the large number of oxidation state possible for the actinoid elements, that is why the chemistry is very difficult. So easily assertion reasoning question can be found here. Actinoid elements are radioactive, very important, right? They are very radioactive elements, right? Short-lived. Actinoid elements have been made only in nanograms quantity nuclear reactions, right? The elements after uranium are called trans-uranium elements, right? Okay, bacha? Yes. So, yes, I think that is the last slide only. So, let's do this. What is important here? Firstly, so you should know that metallic character increases, or you just remember about the metallic character. Along the period, it decreases. Down the group, it increases. Along the period, it decreases. So now, just do this thing. There you have 4 blocks here, right? The elements can be divided in metals and non-metals. Metal comprise of 78% of all the known elements. Very rare are non-metals, and there is proper zigzag thing which is differentiating metals and non-metals. In your NCERT, you have this. In your NCERT, you have this. So these zigzag are the metalloids. Okay, that is the transition. These all are, okay, this blue part is metals. This is also metal. This is also metal, right? And this green part is the non-metal, right? So these underlying elements are the metalloids. So that also you have to remember. What are the metalloids here? You have to underline that, right? So metals, what are the properties of metals? Very simple. They are solids at room temperature, with the exception of mercury that you have done in lower classes. Mercury is liquid at room temperature. Gallium and cesium, Mercury is liquid at room temperature. Gallium and cesium, they can be melt in your arm also. The boiling point the melting point is very low, right? Very low, almost the room temperature only, right? Metals usually have high melting boiling points, right? They have good conductors, right? They are saying they have good conductors of heat and electricity, right? They are malleable, ductile. Malleable means cut down into sheet, ductile means cut down into wires. You have done that in lower classes, right? In contrast, this they will not ask you. Properties of metal, non-metal, they will not ask you. If they ask you, that is a very, very easy question based on the NEET exam. If we talk about the NEET exam. In contrast, non-metals are located at the top right side that I have already shown you. Now, from here, which is the important line, non-metals are usually solids or gases at room temperature, low melting point and boiling points. Boron and carbon are the exceptions. Very, very important. Boron and carbon have high melting and boiling points, right? They are poor conductor of heat and electricity. Non-metallic solids, brittle, that means very hard, right? Brittle and are neither malleable nor ductile. So basically properties of non-metals only. Now, metallic character done. Okay, now you see this thing. The elements silicon, germanium, now mark this important, silicon, germanium, arsenic, antimony, tellurium are the metalloids or semi-metals. That is actually a diagonal boundary that is shift from metallic to non-metallic character, right? So rest of them is very, very simple. Left to right, I've already told you. The simpler way I am writing it here, and then I think we will be done with this. Now everybody in the chat box, now I think there is Shreyas sir lecture that he is going to start here. I already took so much time, right? So everybody, did you enjoy the today's class? Did you enjoy today's class or not? In the chat box, I want to see that in the chat box, everybody. Metallic decreases, here metallic increases, right? Here metallic increases. Okay, Bacha? So now I have a homework question for you. I have one homework question for you. I want all of you to do that. You have to write names of the official name and as well as the IUPAC name. IUPAC name and the official name. And the official name of 114, 104, 105. Okay, you have to write down the official names and the IUPAC name of these three things. In the comment section, I will see how many of you actually write it down in the comment section. Now let us see how many of you actually do your homework. So this is your... also have one more thing for you. By the time I am doing that, I also have one more thing that is for your NEET preparation. We have a very, very big surprise for you. That is your NEET PCB Tatva particle books, okay? So, Tatva books, that is dropper full course at 3777, right? Then, bacha, you have NEET PCB Tatva practice books, only Tatva practice books for class 12th, that is at 1899. Now, if you want to do only for class 11, that is at 1899. Now, this is what I would prefer, that you will have a proper set of 25 books, droppers full course books. You will have PCB Tatva practice books for class 11, 12th and droppers. Now, I would highly advise you, because just by reading the NCERT, very, very important, I agree. Doing the theory part, the concept should be clear. I totally agree with that. But without practice, nothing is going to happen. So I met students, the biggest mistake that students are doing, they are doing the biggest mistake. They are solving everything. You don't have to solve everything, right? You will get confused. Solve NCERT, solve Tatva modules. We have Tatva modules for you that has all the level of questions there, right? Solve NCERT, solve Tatva modules, solve PYQs. Do that again and again and again and again. that would be sufficient. But at least do that. Okay, just don't. Okay, for periodic classification, I'll do questions from all the books. Then in the end, you will leave other books also. You will leave other chapters. That means you have given your 100% in one chapter. Maybe from that chapter you will get 1 to 2 questions, right? But you're not doing other chapters. For that, you need to have a proper set of questions, quality questions that you can rely on, and that is there in the Tatva books, right? Because we know, we have gone through the material of Tatva books, we have seen that material, only then I am advising you for that, right? Only then I am advising you, because they are actually, we have SMEs that see that if there is any mistake, and there are also mistakes, if there are mistakes, then that are also already, like, that are also already rectified there. You will see no mistake in Tatva book. Also, you have your QR scanner, right? So I have already shown you the Tatva book PDF here, right? So I know that if you want to do practice, you will definitely purchase this thing, that is your 11th and 12th, not this, right? Why I am not saying this? Because most of you are droppers. For you, this is the best. For those who are in class 12th, for them also I would advise class 11th and 12th. If you have already class 11, then it is only by class 12th. And those who are actually there in class 11th, I would advise you to only purchase class 12th, class 11th, right? If you are skeptical about it. But if you are sure about it, then do this thing, right? That is the best combo that you can get. Okay, so I'll see your comments firstly here. I'll see your comments here, and then you should go to Share Sir's class. Now let us see the comments here. Now let us see who is actually there, who is actually active in the comments. Okay, how many of you actually did your homework in the chat box? How many of you actually did your homework? So yeah, in the last session I taught you, we started coordination chemistry, right? So the students, my lovable students, my favorite students are, right? Thank you so much, Lakshmi ma'am, the way you're teaching extraordinary, but okay, chapter wise. Okay, bacha, I'll do that. We have zero knowledge, so please help me, ma'am. Okay, beta, don't worry about that. I am teaching you chapter wise only. That is why, firstly, I have taken structure of atom, right? After that, I have taken chemical bonding. After that, I am taking coordination chemistry. So that is the sequence. Don't go through the chapter wise of NCERT. See the content in that chapter, right? To study chemical bonding, you have to know what is structure of atom. Right? Then you have Palani, then you have Tanuja, Saviti, Kirti, Amanat, Hemant, Rajendra, Binod, Abdul, then Saran, then Indra. Very good. So these are the students who do their homework. I want all of you, all the students that are present here, do your homework, and I want to see your comments in the chat box answering this. And if you like this series, if you want me to continue this series, then also write it down in the chat box. Okay? Yes, bacho. Now, bye-bye. Take care. See you all in the next class. And beta, the periodic classification, I will continue that in the series of NCERT line. Okay? The timing will be 7 p.m. Right? Okay? So, timing will be 7 p.m. every Wednesday. Okay, bacha? Now, what about the coordination chemistry that I am going to teach you? The session is already there. You need to like the session as well, right? Firstly, go here, and there is this session scheduled for 9th of August at 11 a.m. So this is our favorite Baswa sir, right? And he is showing that, okay, the response of DNA batch students, right? The response is seriously amazing. The response is seriously amazing. You can see that the response is awesome, dude. Awesome. So I want all of you to like this session before 11 p.m. 9th of August, right? So we will do coordination chemistry, we will do isomerism, we will do structural and stereoisomerism in a very 3D form, just the way we did Vesper theory in chemical bonding. So I hope so you are all very, very excited for that. And but I want to see your comments in the video answering that, because only then after the video I'll be able to understand who is actually sincere enough to do the homework. Okay, if you're not going to do homework, then I think you're only going to break my heart, nothing more, right? So I think that is very sad that if I can stand here for 3, 4, 5, 6 hours. You can't even do the homework. Very, very sad, right? So I don't want you to be that, right? Okay then, bye-bye. Take care. See you all in the next class. Bye-bye.